Thank you for your introduction. I'm Takatoshi Yoshida, and I'm a PhD student from University of Tokyo. Today, I talk about Phyxel, realistic display of shape and appearance using physical objects with high-speed pixelated lighting. There are many approaches to create realistic images. To take an example, by computer graphics, we can create very realistic image in digital world. For another example, stop-motion animation has been developed as a method to create novel visual effect, as if the real objects are actually moving. However, these techniques are developed on the premise of such conventional flat displays. So there are many limitations, such as no motion products, and no binocular fusion, and low light field fidelity. Therefore, many researchers have been trying to overcome these limitations. To take an example, spatial AR aims to reproduce shape and appearance simultaneously using projector and physical model. But usually, it's limited to static objects, and its appearance depends on the surface of the object. Also, 3D zoetrope in the middle figure is a very effective method which is able to make human perceive as if the real objects are really moving. However, this type of motion is limited to short periodical contents. In addition, volumetric displays can express any 3D shapes as you like, but generally, it's not real due to lack of appearance of physical objects. There are moderately trade-off relationship between image reality and content flexibility. So we aim to achieve both of them simultaneously. So in order to display realistic shape and appearance simultaneously, we use physical objects as display components. The core idea is quite simple. If you want to display a shiny metal, you should use real metal as a display component. We prepared various materials such as white wool, red beads, shiny metals, and so on. Using our method, we can perceive that physical objects are moving and relocating at arbitrary position. We call this technology Phyxel, which stands for physical pixels. So now I talk about the principle of our system. In addition to physical objects, we use computational illumination. There are two key devices in our system. The one is high-speed projector, which projects patterned light at more than 1,000 FPS. And the other is a rotating disc with various physical objects. Since projection and actuation are highly synchronized, part of the objects are illuminated at each moment. So please see the left movie of high-speed playback. You can see that the projected pattern is changing according to actuation of objects. This projection is much faster than temporal resolution of human eyes, so we can perceive complete image for the naked eyes. As you can see in right figure, right movie, we perceive temporally integrated image on the retina due to persistence of vision. In our system, there are three key parameters. The periodic frequency of actuation is related to refresh rate of pixel display. To keep the visibility, small f is determined to be around 30 Hz. This parameter is related to critical fusion frequency. The number of objects are related to degree of freedom for appearance expression. Since the projection sequence have been finished in small time of persistence of vision, the frame rate of the projector must be larger than multiplication of actuation frequency and number of objects. For example, if we want to use 10 objects for video rate around 30 Hz display, you have to use projector with more than 300 FPS. So this is how to generate lighting patterns from an empty image. The location of object is changing as objects are moving. Generated patterns are intersections of empty image and the location of object at each moment. In order to implement a prototype, we use high-speed DLP projector as a pixelated lighting source. Also, we used the sub-motor for periodic actuation. Both of these are synchronized and controlled from the same computer. For physical objects, we prepared various objects on the disk. In addition to 2D flat arrangement, we also used layered objects with different height and 3D printed objects. I'll explain each characteristics of various materials later in detail. For applications, we developed 3 types of demonstration. And this is the first type demonstration. We call this demonstration dynamic stop motion. In real time, for your naked eyes, we can perceive animation of real objects. As you can see, the red pelleted car actually moving and passing by the green wood tree. This is the second type of demonstration. If you prepare various layers with different height, we can create 3D shape with physical appearance of objects. This demonstration uses wood and blue shiny fabric. We call this layered 3D display. Since motion parallax and binocular fusion are consistent to real objects, the shape and appearance are so natural for our perception. 3D printed objects can be also used for our Phyxel system. We can cut, we can cut and paste some figures by pattern, right? And we are able to create new shape. For example, in this demonstration, using lower part of 3D printed horse and upper part of the human, we can create an imaginary creature. So this is the conclusion of my presentation. Please come to Open Labs at the University of Tokyo on the day after tomorrow and enjoy our demos for your naked eyes. Thank you. Thank you for listening.
Okay, before we take questions, I just want to let you know that I have an important slide after the end of questions that will tell you a little bit about the lunchtime meetings that are happening and also places to eat lunch, so stick around after that. All right, questions? Questions? While you think of questions, I have a question for you. Right now, your implementation is a radial disk, but it doesn't have to be a disk, right? As long as it's a periodic object, this technique should theoretically work, correct?
Yeah, still once more, please.
Oh, so it doesn't necessarily have to be a radial disk, right? Radial, like a circle. It doesn't have to be a circular disk. Anything with periodic motion with multiple materials that goes through all of the positions should work, correct?
Yes, yeah, it's correct. The current prototype, we use circular motion. However, another type of periodic motion, such as a belt conveyor type, and or other periodic motion is applicable.
Do we have any other questions? If not, let's please thank the speaker.
Thank you.